All right, ATT, we're going to look at section 5E here, our modeling real-world situations using quadratic functions. And you can see I've already actually matched this first part here, but we're going to talk through it just a little bit. So if I'm looking at the flight of something, a projectile, some kind of ball thrown in the air, and when it hits the ground, how high does it get? What time does it get to that height? Where does it start? We can get all of this information from the graph, and we can answer each of these questions. So this first one says, how long was the ball in the air? So if you consider looking at this graph and seeing it kind of launch from a little under 10 feet here, and it launches up, and eventually it comes down to where the height is 0, and it hits the ground. That's what we're worried about there. That's called our x-intercept, and that's the answer to number 1. We're looking for the x-intercept when the height is 0, because when the ball's height is 0, that's the time that it's hitting the ground. So you'll notice we have B, find the positive x-intercept by setting the y equal to 0, right? You're setting your height equal to 0, and we'll see that later in an example in this same video. Notice also it says the positive x-intercept. Technically here, we have another x-intercept, but this is like negative something or other. I don't know exactly what that is, but it wouldn't make sense to have that as an answer in terms of time because we can't have negative seconds. So I'm not really worried about that x-intercept. I'm really only worried about that one as far as when does the ball hit the ground. Numbers 2 and 4 are answered by the same point. What's the maximum height of the ball? And then what time did the ball reach that maximum height? And for those questions, we're looking at the vertex. All right, our x value is going to give us the time. If you think about where that x value is, it's at, say 1.2-ish here. X value gives us the time, and the y value is what's going to give us that maximum height. So number 4, the max height, is answered by the y value, or sorry, by number 4, the time of the max height is answered by the x value. Number 2, what is the max height, is answered by the y value. You have to find the x value first by using this equation, x equals the opposite of b over 2a. That'll give you an x value, and then you substitute that into your equation, which you'll have for a problem like this, and that will give you the y value, or the max height, at that point. The last question that we can answer looking at this graph is the starting height of the ball. And the starting height, think of that as when time is equal to 0, right? Right at the beginning, before that ball is released, how high is it? So if I look at when time is equal to 0, I can see that it's right here, I don't know, maybe 8 feet or so in the air. And that is answered by our y-intercept. The y-intercept occurs when x, or time, equals 0. So we would simply put 0 into our equation for the x value, and it would turn out a y value that would give us the y-intercept. Here it looks like we can approximate it at 8-ish feet or so, but we're not able to exactly say that until we use an equation. So now, looking at number 6 here, we're going to actually look at an equation and answer some of these questions using those equations instead of just looking at a graph, kind of backing up what we were saying up above. So at this point, you might want to pause and try number 6 on your own and come back, but I'm going to take you through what number 6 looks like. So we've got an equation that models the height of a ball in feet, h of t, after t seconds from being thrown up into the air. So the first question is, how high is the ball when it's thrown? So I'm just going to kind of graph what could be sort of the flight of our ball here. And how high is the ball when it's thrown? Well, I'm worried about the y-intercept here. And up above, for the y-intercept, we said you want to let x equal 0, or in our case, t equal 0, right? Because the time is 0 seconds. So I'm going to plug that in. H evaluated at 0, right? The height at 0 seconds is equal to negative 16 times 0 squared plus 25 times 0 plus 4. You'll notice, those first two terms turn into 0, right? 0 squared is 0 times negative 16, still 0, plus 25 times 0, still 0. So we're really just left with an answer of 4. So we would say that the height of the ball is 4 feet to start. That's our y-intercept. It's technically the point there at 0, 4. When 0 seconds in, the ball's 4 feet in the air. Next question says, at what time does the ball reach its maximum height? All right, and then in part C, what is the ball's maximum height? Both of these questions are worrying about our vertex here, right? Our vertex is going to tell us not only how high did that ball get, the y value, but when did it get there? That's our x value. In order to find the y value, we need the x value first. So we're going to start there. It says show working round to the nearest tenth. We know that the x value of a vertex is given by the equation the opposite of b over 2a. So I'm going to look at my equation and label out my a and b and c here. A is negative 16, b is 25, and c is 4. You can see each of those in those coefficients right out in front of the t values there, and c being 4, our y-intercept, right in that equation. So to find the x value of that vertex, I'm going to substitute those in. Opposite of b, that's negative 25 over 2 times a. A is negative 16. So I'm doing negative 25 divided by negative 32 here. I'm going to put that in my calculator, and I end up with approximately 0.78. So I'm going to round that to the nearest tenth. So we're going to call that approximately 0.8 seconds, right? That's an x value. So I've got my x value there at roughly 0.8 seconds. So as I label that there at 0.8 and then some y value, which is that max height. So I'm going to answer that in part C. Well, what is that height? I know it occurs when x is 0.8. So if I know that x, or in this case, I should say t, is 0.8, I'm going to substitute 0.8 into my equation and evaluate what's the height at 0.8 seconds. So that's going to be negative 16 times 0.8 squared plus 25 times 0.8 plus 4. And now I will literally type that exact thing into my calculator. Don't need to do it in steps. If you are careful with your parentheses and your exponents, you can type it exactly in as you see it. So as I'm doing that here, negative 16 times 0.8 squared plus 25 times 0.8 plus 4, and I get 13.76. We'll round that to approximately 13.8 feet in the air. And that's my maximum height, roughly 13.8 feet in the air. Kind of makes sense. Threw it from 4 feet, gets a little higher. About 0.8 seconds in, it's almost 14 feet in the air, and then it's going to eventually fall to the ground. So that vertex gives you not only the time it's at its maximum height, but also what that height is. Last question is, how long is the ball in the air, right? When does that ball hit the ground? We're worried about that point right there, that x-intercept. Reminder that there's also that other x-intercept, but we don't really care about this one because that's with negative time, and time doesn't really go negative. So we're worried about the positive number of seconds to when that ball hits the ground. So we know that in that case, the height is equal to 0. So I'm going to set this entire equation, negative 16t squared plus 25t plus 4. I'm going to know what's the time when the height is 0. We've already got our a, b, and c values. So in this case, I could try and factor, but I'm going to go with the quadratic formula. I think it might be a little bit easier just because of that negative 16 out in front there. So I know that x equals the opposite of b, in that case, negative 25, plus or minus the square root of b squared, 25 squared, minus 4 times a, which is negative 16, times c, which is 4, all underneath the square root, and then all of that is divided by 2 times a, or 2 times negative 16. All right, again, this formula will be provided to you. It's also on in your review packet. Now I'm going to focus just on that chunk inside the square root there. So I know it's going to be x equals negative 25 plus or minus the square root of something, all divided by, I think that's negative 32 if I multiply 2 times negative 16. So we got to figure out, well, what's underneath that square root? And I'm going to type that into my calculator, right? I'll put that chunk, that highlighted part, right into the calculator. 25 squared minus 4 times parentheses negative 16, parentheses 4, and I get 881 underneath that square root. Now, 881 is not necessarily a perfect square, So I will have to take the square root of that number. So I'm going to do the square root of 881 in my calculator, and I get roughly 29.68, so we'll call it 29.7. So I know x equals negative 25 plus or minus roughly 29.7, all divided by negative 32. Now, a reminder, I'm going to get two answers here, right? I'm going to get the answer that I don't really care about and the answer that I do care about. So we'll see which one gives us which here. So we'll go a plus route and a minus route. So I'm going to do negative 25 plus 29.7, divided that by negative 32, and negative 25 minus 29.7, and divide that by negative 32. Each of these, I'm going to enter that numerator before I hit the divided by. So I'm going to do negative 25 plus 29.7. I get 4.7, then divide that by negative 32, and I get roughly negative 0.1. So I get negative 0.1, which again isn't going to give us really an answer, but we'll get to that. Negative 25 minus 29.7, that's negative 54.7. Divide that by negative 32, and I get roughly 1.7 seconds. That's an answer I can live with, right? That's a positive value of seconds. All right, I know at 1.7 seconds, the ball hits the ground, so that would be my final answer there. This negative 0.01, that's this point over here that we said like mathematically exists, but in the terms of our problem, doesn't really make sense. So we're going to eliminate that negative time. So there you have it, kind of each of those types of points that you're going to need to find in 5E. Go ahead and email your teacher or ask any questions in class, and good luck on your test.